Appreciate it. Morning, everybody. So I tried being serious on the first slide, and that didn't really feel correct. But this is the language Madlib. I've mainly spent most of my career working primarily in JavaScript. There are parts of it that I love, there are parts of it that I really hate. There's a book that you may know in the space of JavaScript. It's called Douglas Crockford's The Good Parts. And I think in general, there's a really elegant core to JavaScript, but there's a lot of really poorly designed choices on top of that. Least of which is it's a prototypical inheritance language. But that even aside, it's a complex language that I found it to be frustrating because it's largely become the de facto language of the web. But at the same time, it is the types that it has, and there have been multiple attempts. Currently, TypeScript is sort of the best, and I think it's very weak. It is inconsistent, and you can comment away the typing, and that kind of means that you can't really trust it very well. I think it functions better as a compile time language or compile time helper than an actual language. But so by contrast, if you played with Haskell, it's a very different paradigm. But I think once it makes concrete sense, it becomes really valuable and interesting in terms of applying sort of the I find Haskell interesting and powerful because it allows you to encapsulate ideas in a way that is both complex and easy to reason about. And so this is the question I posed to my buddy Arnaud back in, I think it was August 2020. And we thought that it would be a very simple, reasonably simple idea to add Haskell types to JavaScript. And we were very wrong, but I think as with so many good projects, it requires that you commit. And so I like that this has been, there are times where neither of us are doing very much, but we've continued sort of pitching in over years. Here's sort of where we're at today. We're still not at a core version 1, but I'm just going to quickly go through some of these, and then I'm going to try and get to mainly sort of talking about using the language and some of the choices we've made. But out of the box, well, and specifically a lot of this was chosen as a result of working in JavaScript and Node and feeling that there are utilities that exist, but they're not well considered and they're not robust. And often they are built in userland. And so it requires that the community takes the time to build them. And thus there's no, JavaScript is powerful because the barrier to entry is very low, but that also means that the quality and the discoverability of packages is also low. So going through these somewhat quickly, we have a language server, gives you real-time updates as you type. It's really exciting. It works in VS Code and in Vim. I have not used the VS Code one because I'm a Vim person, but I am told it is also excellent. We have automatic formatting. The only configuration that we give it is what your preferred width is for a file, and everything else is automatic. We have built-in testing. We have, so currently we're piggybacking on NPM as a package manager generally. So we can install via NPM, but also we can have privatized packages. We have a generator, we have a bundler, we have automatic documentation generation, which I can show right now. So this is the site, Madlib space, if you want to take a look. But this is automatically generated. And so control here, I can jump to control, and we can kind of see this matches up with the data in here. And that's pretty, in my mind, this was something that I found frustrating in extant both JavaScript and other languages. I think Julia does this and dlang does this, but one of our goals is to make it so that these examples eventually function as tests. Currently, we're not yet doing that, but that's one of the things we sort of just have built in, which is pretty cool. And also, this website is built largely automatically. So there's a tool that generates the documentation JSON, and then a separate tool that spits up a website for you. Coming back, so I mentioned before, in TypeScript, you can put what's called a ts_ignore tag on something, and it basically just tells TypeScript to stop paying attention to the next line. And that's, it gives a specific affordance, but it's also very dangerous. And what we've had sort of from the beginning is this idea of the fence. And the fence is, it allows us, it's a syntactic structure which you can wrap around existing JavaScript, and then it basically becomes an untyped bit of code that you can then run. And so from the very beginning, we have written parts of our library using raw JavaScript, and then over time we have replaced that JavaScript. I'm a huge fan of function composition and automatic currying, so that is just something we have out of the box. If you're coming from Scala or Haskell, typed holes are a really cool thing, which allow you to basically insert a place where the compiler will barf, but also tell you the correct type in the place where it barfs. We have polymorphic interfaces, we have ADTs, so you can start to think about more complex structures in algebraic fashion. And we have, it's mainly no mutation, limited mutation, largely enclosures. So just quickly, I wanted to mention, like, hindley-milner types are, I'll read it out, classical type system for the lambda calculus with parametric polymorphism. And then the emphasis here, it allows, so I think this is important, high theoretical complexity is correct. Like, I think working with Hindley-Milner types is initially confusing, but once you sort of get it, it's really powerful. This is now actual code you can actually look at. And it's very simple, but this part is the signature, and this is any type A returns the same type A. And again, identity, very simple, but this allows us to, so this is a generic, and it can be instantiated. If we called it with like 100, then it would be an integer returning an integer. And this pattern, it comes from Haskell, but it's sort of like, this is one value, this is the return value. But if you have multiple things, it becomes slightly more complex. And because I can do syntax highlighting on our site, but I don't yet have it for this setup. So I wanted to see. So actually, what's the best way? I think I can do this. Cool. So we're going to, also, we recently added a REPL, which is kind of cool. But we can do, oh, right. So this is within the REPL, it does inference automatically for you. And so there I specify a type. And here I can do the type, and it knows that this can either be an integer or float. And so this is sort of like, we're starting to walk through it. And additionally, I can also show, let's see. So here's with some syntax highlighting. And it feels, in parts, it feels hopefully a lot like JavaScript, like aside from the position of the export and the fact that there's no const. But coming through, so these are sort of the basics here for primitives. This one is one I wrote up last night for, so this sort of is how you can think about types, and I wrote this up here. So I can quickly walk through it, but also if anybody has any questions, please either type them out or ask. I'm happy to answer. But so to sort of give a sense, this is type temperature. It can be one of these three kinds. All of them are floats for simplicity. This is a constant. This is math to basically take a digit, turn it into a way of rounding. And these sort of are very straight from Google, because I haven't done them in a while, conversion between Fahrenheit and Celsius and Kelvin. So high level here, these are constructors. And so if I want to, I can create a Celsius of 5. In fact, I can comment this out and show you. So here I've constructed it. I could assign it to a value. In this case, I'm going to print it, 32, and 32 Celsius, cool. So this, and yes, it is Vim. And, but, so the sort of setup here is that these are these are constructors. This is the type. And so I use the type when I'm talking in signature form, but I use the constructors when I'm talking in concrete implementation. So temperature to temperature, so we're using the where construct here as a way of destructuring almost anything. There's some edges to it. And there's also some syntax that we support that I don't actually know how to use, so I neglected to write it here. But basically, we get a value. It is T. We say where T, and then I say if T is Fahrenheit, do this and wrap it in Celsius, and otherwise just return T. So Fahrenheit to Celsius, if you give it something that is not Fahrenheit, it will do nothing. Then within this, there are a couple sort of different conversions here, but I wanted to get to down here. This is the composition feature that we have. And also, we're also supporting the JavaScript pipeline operator. I find it is I find it's nice for a single line, but a little ugly, and I'm used to pipe. But that aside, the thing that's cool here is I can prove that Kelvin to Fahrenheit works by converting first to Celsius and then to Fahrenheit through composition. And so it's really exciting. I really love it. This is sort of an example. An apology, I have a sweeper going by. And back. So here, temp map is a simple idea. Takes a function and a temperature, and where that temperature is, it then applies it to that function or to that value, and then wraps it back up in that same kind. And so I largely did that so that I could write this simply last night when I was sleepy. Because, so now we sort of have this high level thing, and round temp to precision, it takes a float and a temperature. And another cool thing is because these are automatically curried, I could just partially apply them and name them. And so coming back out from here, I can print the thing I originally had and see it. And you can kind of see, I wrote the precision thing because floating numbers get really big. And so Kelvin here is really big, and then I started rounding it off. But it's nice because you can see I start at 72 and I work all the way back. So that's sort of like a simple concept. We have a bunch of built-in types. Many of them are things you're probably familiar with. Maybes and eithers are really awesome for disjoint types. So you can capture things that are impossible. So as for instance, And this is always dangerous, but also good because it's a demo. So I believe like here, list, one of the things that we have is, I'm trying to remember this. Basically, one of the, yes, I remember now. I have a specific challenge coming up. Yes, okay. Apologies. So this is not quite right, but I wanted to start with this and sort of show how I find it really valuable how this language sort of helps you get it correct. So let's go from the top. So this is what we have, and it immediately starts yelling at us. So that's cool. So import list. And now it is more mad about different things. Also, this is one of the things that is both exciting and frustrating about being largely a two-person team is like, this works, but I can't read it. And that's something I have to build myself. So that's just something I kind of find that is interesting in sort of working around how this is. So here I'm actually just going to run it because it's easier for me to read. Oops. Unless it's not written, I want to find it. Live demo, right? So there's 2 or 3 things it's mad about. One is I'm defining a thing, but I'm not exporting it, which it's mad about if you're not going to use it. The other thing is unlike, so this took some discussion, but we've decided to have a main function to allow for executables, but you don't have to have a main if you're not trying to run the file. So it sort of gives a trade-off between libraries and runnables. But here, so now that I've added a main, it should be mad about something else. So here, list user, user, list user, right? So this was what I wanted to mention. So what I wrote originally was find by ID, but we're using filter. And so find, and again, coolly, we can see if this works. So you'll note that this takes a predicate function, takes a list of A, and returns maybe A. And that's powerful, but also doesn't match the type signature that we have here. So either this should be maybe user and use find, or in this case, since I'm going to build to a different thing, I'm just going to rename these 2 things. Cool. So this should now compile. Great. And now I should be able to, in fact, since I did some of this, cool. So pretend that I've jumped forward in the future. We've added a few things since we last talked. This allows some coercion between uppercase and lowercase. This is a simple thing for formatting. Oh, and also, if I didn't mention, alias here is, it's not a concrete type, it's this, but it allows us to give sort of a name to it and then use it within signatures. Here, so filter by last name allows us to take last name, convert it to lowercase, compare it to a list of things that are being filtered, and X here is each person as you iterate. So here I have defined some very cool people with cool names. Filter and format. So as you can see, last name cool, print people with last name cool, and again, lowercase because I'm lazy, and then pipeline operator so you can print it. The other thing I wanted to talk about, because I think this is really powerful, is it gets really mad if I have incongruent types. So let's say that Frederick has an age and he's 50. You can almost read that, but you can't. So specifically, it says, hey, there's an age here, and it's not consistent. But if instead I go up to my person here, and I go age here, and come back down, well, same issue, but I can quickly think at this point it will be happy. Great. So, but I like that it basically enforces congruence of types. I think it's really valuable because then if you make it's much easier to reason about a system that knows what's happening than one that is basically always trying to catch you. Appreciate that, Matt. And I'm pretty pleased with how well it's going because I've only made a few mistakes and mainly working. But yeah, so high level, this is sort of the language. I kind of figured I would pause here for questions. There's a lot of stuff that we have. As for instance, this is all running on the server. This is interpreted and runs. We are working on a number of different other things. So currently, you can copy these and basically just paste them in. And run that, and now it does a different thing. So that's how it kind of works today. What we're hoping to have soon is to make it so that this playground exists on every page, and so you can start to kind of have an overlay of content that you interact with. It's also like one of the things that's exciting and both exciting and frustrating is how many things we've built, but also how many things we still have to build. So this website is built with Madlib, and it leverages all of the, not all of these, but most of these. We had to write our own markdown parser and renderer. We have a JSON parser and renderer that is now part of our core standard library. We, again, the documentation tools, we're really excited with where we're at, and also we're 2 people. So truly, if anyone has any excitement from this and feels like engaging, please, we would love more people to engage. But yeah, I wanted to just quickly mention here, this is the fence, and it is syntactically a way of basically dropping to raw JavaScript. There's also a pattern, I don't know if it's documented yet. Yay. So we also have this for llvm, which are binaries. And there's some very cool things that, because we write it in one language, we can target multiple binaries. It's pretty interesting to see the spaces in which you can kind of put this stuff. Yeah, I think that's sort of where I'm at, but does anyone have any questions?
This is really cool, Brekk. I appreciate this. I don't know if I have a question, but no, I just want to say that this is really cool to see.
Thanks. I'm pretty excited about it. But yeah, truly, if anybody has any deeper interest, feel free. I'm always happy to talk. And in general, it's been really interesting to sort of find the edges of where we think things are valuable and where we think things are hard. Because I think JavaScript is really, it used to be one of the most exciting things to me. And I've gotten so frustrated with where I think it's headed. And I think TypeScript is such a terrible mess. So yeah, that's the sort of hope here, is that you can start to see where this is headed. And we have a bunch of new things coming on the horizon, including rewriting the language in Madlib itself, or rewriting the parser in Madlib itself.